Let me share my screen. All right, so I'll give you like, just to, to start this session right here. So find the vertex. All right, so I let you sometimes to do this. Find the vertex of these two right there. Okay, I was muting myself. So what is the vertex for the first one? Can somebody tell me the answer?
Is it 2?
I mean, the vertex is a point, right? The X and the H and the K. What is the whole point? You said 2, right? And what is the Y? What is the H? The K.
Not sure.
You're not sure?
No.
Somebody got the answer for the K?
7. Q 7.
Okay, so let's check that. So we do first negative B over 2A, right? The B is 20, is going to be negative 20 over 2 times negative 5. So which is negative 20 over negative 10, which is 2, right? You see, when we ask you what is a vertex, and you say the vertex is 2, the format of the answer is not a good format. The vertex is always a point. And when we give the point as an answer, you have to give an X coordinate and a Y coordinate, right? Always. They can be wrong, but at least the format should be right, you know? So that's the vertex is a point. So now what you do to the 2 now? We're going to plug in the 2 back into the equation. So f of 2 is negative 5 times 2 squared plus 20 times 2 minus 13, which is negative 20 plus 40 minus 13, which is 7, right? So the vertex is 2, 7. The other one, for the vertex, it will have some type of fraction, right? Okay, so I do same thing. Negative B over 2A is negative 3 over 2 times 1, which is 3/2, right? Now what I do next is f of 3/2, which is 3/2 all squared, minus 3 times 3/2 plus 7, right? So it's going to be 9 over 4 minus 9 over 2 plus 7. If you write everybody as, you know, same denominators like over 1, you see, some by 2, LCD is 4, some by 4, some by 4. It's going to be 9 minus 18, which is negative 9, plus 28, which is 19 over 4. So the vertex is 3 over 2, 19 over 4. All right. So don't forget that. I think this is way, way easier than to find, you know, the vertex form. Now look now. What the vertex form does tell me. If I have f of x is equal to a times x minus h squared plus k. Look, what the vertex tells me. If I consider the original parabola x squared, f of x equal x squared. The vertex tells me, the h tells me how much I should go right or left. So the vertex is hk. The h tells me how much we go right or left. It depends on what is this, if the h is positive or negative, right? And the k tells me how much we go up or down. And when you multiply by a outside, do you remember what you have to do? When you multiply by something outside, do you remember the action we have to do? A f of x. Do you remember a f of x? What is the action?
Stretch.
Stretch or shrink, right? The range. Stretch or shrink the range, right? So basically, I give you an example. Just how we use a vertex, right? So basically I have this. I have f of x equal, right, x 2 times x minus 1 squared plus 3. And this is my original parabola right here. My original parabola is, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Right? This is my original parabola. What is a vertex from here? What is a vertex? What point is a vertex? What point is a vertex?
0, 0.
I mean, this is a parabola, the black one, but this one right here, the 2 times x minus 1 squared plus 3. What is a vertex?
Is it 1, 3?
1, 3, thank you. It is 1, 3. So 1 tells me if I want to graph this one right here, if I want to graph f of x from this graph, the number 1 tells me how much I should go right, you see? The number 1 tells me I have to shift right 1 unit. Which means my new vertex will be here. 1 here. And I have to go, how much I have to go up? Up 3. You see, and then I go up 3. 1 here, 1, 2, 3. This is going to be my new vertex. Okay? My new parabola here is shifted 1 to the right and 3 up. Everybody shifts 1 right, 3 up. You see this point right here? This point right here? How is this point? What's this point going to become? It's going to become 1 right and 3 up. This point right here, all of them, this point 1 right, 3 up. So 1, 2, 3 is going to be like that, right? This is going to be my new parabola. Okay, that is just before the 2. What the number 2 does? The 2 want to stretch the parabola vertically, right? So I'm just here. My focus is more what the vertex means for the transformation. The vertex tells you always, the H tells you how much you go right or left, and the K tells you how much you go up or down, right? From the original parabola, which is f of x equal x squared. The vertex tells you the H, tells you the horizontal transformation, and the K tells you the vertical transformation, okay? So, but if I wanna graph a parabola in general, I don't need like a lot of points. I need some particular points, right? I need only some particular points. Are we gonna say what they are? Let's say I have my parabola like this. I have some parabolas, some points that are important. I have, first of all, the vertex is very important, right? And we have just seen how to find the vertex, right? We have seen how to find the vertex. So to find the vertex, use what? Use the vertex formula. What other point is very, very important? This one right here. How we call this point? How we call this point? What's the name?
Y-intercept.
Y-intercept. Thank you. Now, for any function, do you remember for any function how to get the y-intercept? By doing what? By plugging in what number?
0 for x.
Exactly. Thank you very much. For any function, the y-intercept is always f of 0, right? Now, in particular, for a quadratic function, which is f of x equal to ax squared plus bx plus c, what number is going to be the y-intercept? How much is the f of 0? When you plug in 0 for x, what you end up having?
C.
You end up having C, right? So the y-intercept is always C, right? For a quadratic function, the y-intercept is always C, never changes, always C. Now, what are the two other points that are very, very important? These 2 points right here, if they exist. And what are they? They are the x-intercept, right? Sometimes they don't exist, okay? Sometimes you have only one x-intercept. Sometimes you don't have no x-intercept, okay? And how to get these? The x-intercept now, what is equal to 0 now? Is the y, right? For the x-intercept, the whole thing is equal to 0. And if you want to solve the whole thing equal to 0, what you have to use? What tool? What is the principal tool you have to use to solve the quadratic function equal to 0? You have to use what is the principal tool we have to solve a quadratic equation equal to 0? Use a quadratic formula, right? Or factor. All right? Use a quadratic formula or you factor. So now, any parabola has what we call an axis of symmetry, which is any parabola can be cut in half, and one half will be exactly equal to the other half. And that axis of symmetry is this line right here. This line is the line x equal h, right? This is the axis of symmetry. This is exactly the middle of the parabola. Any parabola can be cut in half. The left side will be exactly like the right side, you see, and that line is x equal h. These are the principal features of the parabola, okay? So let's give an example right here. For instance, if I ask you, f of x equals x squared minus 4x, right, plus 3, find the vertex, find the y-intercept, find the x-intercept, and then graph. Find the 4 points here, and then graph. I'll let you find the vertex, I'll let you find the y-intercept, I'll let you find the x-intercept. Remember, the x-intercept is when you solve the equation equal to 0. You either can use a quadratic formula or you either can factor, okay? If the expression is nice enough, if you can factor it. If you cannot factor it, you use a quadratic formula, all right? I'll let you a couple of minutes to find them. And then we're gonna graph. what point is the easiest to figure out among the 4 points? Which one is the easiest to figure out?
I'd say the y-intercept.
The y-intercept. The y-intercept, no calculation whatsoever. What is y-intercept? It is
0.3.
0.3. Thank you very much. It's always 0.3. All right. The vertex. What vertex did you find?
2 and -1.
2, -1, right? So because negative b over 2a is -4 divided by 2 times 1, which is 2. And then f of 2 is 2 squared minus 4 times 2 plus 3, which is -1, right? So my vertex is 2, -1. Now the x-intercept, which way you went? Did you factor or did you use the quadratic formula? For the x-intercept, we have to set the equation x squared minus 4x plus 3 equals 0. You know, if the equation is nice enough that you can factor, can we factor? Go ahead. How we factor this?
So it would be x, what is it, plus 4, and
X
then
plus 4.
x, and then x minus 1.
I would say x minus 1 and x minus 3. I would say that, right?
Oh,
Just,
yeah.
Yeah, I would say x minus 1, x minus 3. So what are the two x-intercepts? So we get x equal 3, x equal 1. So it's going to be 3, 0, or 1, 0, right? So I have my 4 points. 0, 3 is the y-intercept. 2, -1 is the vertex. And my 2 x-intercepts. So now what I do, I go ahead, I just put them on, sorry about that, I just put them on my 0, 3 is x, y-intercept, 1, 2, 3. So that is y-intercept. 2, -1. 1, 2, and then -1 is here. You see, this line right here is the axis of symmetry. This line will be exactly the middle line, which means if I have 3 here, this one also will be a point on the parabola. You see, I have 1, 2 units, 2 units. This one will be the also, a point in the parabola, just to complete. And my 2 y-intercepts are 3, 0, and 1, 0, right? 3 here, 1 here. So I have my 5 points. I just go ahead and that's it. That's how you graph a parabola, okay? So y-intercept is very easy to find. The vertex, we know how to find it. The x-intercept, that is not something new. We just use the quadratic formula, or we just factor if the stuff is nice enough, okay? So now, do you remember, do you remember that application problem that we did in test number 1? We launched something, we launched some type of object, is go up and then comes down. And the question we asked back then was, how long it takes for the object to hit the ground, right? Do you remember that?
Yes.
Now we can ask another question that we only know how to answer right now. We can ask now, what is the maximum height the object will reach? What is the maximum height the object will reach? How long is going to take for the object to reach the maximum height? You see, now we can ask that question. And if you're talking about a parabola, when you hear the word maximum or minimum, what point comes to your mind?
The vertex.
The vertex. Every time, if I'm talking about a parabola, when I hear the word maximum or I hear the word minimum, the point, the vertex come to my mind, right? And we're going to do that application. You see, that application problem, you say an object is launched upward, right? So this is an application problem. So we say an object is launched upward. You see, and the height in feet after t seconds is given by h of t is given by h of t is equal to negative 4.9 t squared plus 15t plus 2, right? And we said this equation comes from somewhere. It comes from physics, okay? But here we said after t seconds, what is the height? The height is described by this. If we ask you, what was the height after 3 seconds, you plug in the number 3 for t, right? What was the height after 10 seconds, you plug in the number 10 after the for t, etc., etc. But we're not asking that. The first question we are asking is, when the object will it reach the maximum height? That is my first question. When the object will it reach the maximum height? You see? Now I'm not asking now for this one, I'm not asking now when the object will hit the ground. We saw that in test number 1. At the ground, the height is 0. We set the equation to 0 and we solved it. We saw that it was even in the test number 1. But here I said, when the object will it reach the maximum height? Because it's talking about the maximum, the answer will be in the vertex, right? Because of this keyword maximum, I know the answer will be in the vertex. Now, the vertex has 2 coordinates, right? The vertex has 2 coordinates, the x coordinate and the y coordinate, the h and the k. When you say when the object will reach the maximum, to answer to that question, the question is it the h or is it the k?
The K.
The k? Let me do this. Let me do this. And the vertex here is, let's say the vertex is 3, 17. When I say, what is the maximum? What is your answer? The 3 or the 17?
17.
17.
My answer will be the 17, right? This is a what. What is the maximum? My answer will be 17. When I say when the maximum is it reach? What will be your answer now? When do we reach the maximum? When?
3.
When x equals 3, right? That's the answer, you see? Every time we ask the question, when do we reach the maximum? The answer is the h. Every time we ask the question, what is the maximum? The answer is the k. Do you agree with that? So now if I come back now, I ask you the question again. What's going to be the answer? The h or the k now? When do we reach the maximum? What's going to be the answer now?
The H.
The h, thank you. The answer will be the h. Very short answer. And what is the h? What is the formula for h? What is the formula for h? Negative b over 2a, right? You see, when the object will reach the maximum, the answer is negative b over 2a. That's it.
Sir, please.
Huh?
I have a question.
Yes, go ahead.
Oh, this looks like physics, right? So
Yeah, it is physics here.
yeah, so I think when the object reach the maximum, it's about the k. This one with the maximum, I think it's the k, right?
No. What is the maximum? If you say what is the maximum value, of course it's going to be the k. But when here, every time when it is after how many seconds, this is the input variable. This is the, this is the t. What time? What time the object will reach the maximum? What time? This is the t. And the t in the vertex is the h, is the first one. Okay? So, but when you ask you what is the maximum height, okay, that is the k now. Okay? So for instance, right here, for this one we say it's 2 seconds.
I got it. It's good. I got it.
You got it? Okay. You see?
Yeah, because we need this k to replace the ht with the k to find the t.
Exactly.
Yeah.
So the answer is negative b over 2a. So every time we ask you, when do we reach a maximum? The answer is the h of the vertex, the first coordinate of the vertex. That is the answer. In this case, it's going to be negative 15 over 2 times negative 4.9, right? Which is, we take our, we have to do some negative, which is 15 over 9.8, right? I do some calculation, is 15 over 9.8, which is about what? 1.53 seconds. The object will reach the maximum height after 1.53 seconds. Okay? The object will reach the maximum height after 1.53 seconds. Now the question B. Now the question B says, what is the maximum height reached by, what is the maximum height reached by the object? Now my answer will be the k of the vertex. The answer is the k of the vertex. And how do we find the k for the vertex? What do we do? What do we do next?
Substitute the h into the original function.
Thank you. Okay. This is how we get the k for the vertex. Substitute the h into the, so it's going to be negative 4.9 times 1.53 squared plus 15 times 1.53 plus 2. And then we do the math, right? Well, we don't like this one right here because the numbers are not nice. But we can try 4.9, negative 4.9 times 1.53 squared, right? Plus 15 times 1.53 plus 2 is 13.48 feet. Do you see that? Again, I repeat again. Every time you see the word maximum into the question or minimum, and we have a parabola, the answer will be in the vertex. Now, which part of the vertex will be the answer? That is the question now. Okay? Very likely, we will not ask you what is the vertex for this type of problem. We will ask you, when do we reach the maximum? what is the maximum? When do we reach the minimum? What is the minimum? These are the questions, the function, the question you're gonna have. When do we reach the maximum? What is the maximum? When do we reach the minimum? What is the minimum? In any case, your answer is in the vertex. Now, when we say when do we reach the maximum, when? If the answer is when do we reach the maximum or minimum, the answer will be the first coordinate of the vertex. If the question is what is the maximum or what is the minimum, the answer is the second coordinate of the vertex. Okay. So that is, some application problems. This is, we use this application problem a lot. Now the context can change. We can talk about the business. The profit function is a quadratic function. How many items we have to? How many items? You see, for instance, we say this is f of x equal to 1.32 x squared, minus 17x plus 500, etc., etc. No, that's too much. Plus 5, etc. And we say this function represents the profit we make when we sell X items. You see, the context can change, but it's going to be the same stuff. This function represents the profit we make when we sell X items from something, right? And then we can ask the questions, what is the minimum profit? When do we reach the minimum profit? You see? Why I say minimum instead of maximum? Because here, my parabola opens up, right? Now it is, since my parabola opens up, so I'm talking about a minimum. When I say, when do we reach the minimum? When do we make the minimum profit? When? It is the h of the vertex. It's going to be 17 over 2.64. What is the minimum profit? Then we have to plug in that number to get the k, etc., etc. Right? All right, so in this topic right here, 3.1, we have seen what is a quadratic function, how to find the vertex, very important. What is the vertex form versus the general form, and what is the vertex formula, and how to graph a quadratic function. I have to say this is not new. This is like a actual review from OAD3. I have an OAD3 class. How are we going to do that? Okay. So now what we're going to do more is we're going to see polynomials in general, right? 0.2 polynomials. We're going to define what is a polynomial, and then we're going to try to graph some of them. We're going to define, this opened up a very, very important topic in this chapter, very, very important. So the word polynomial is not new to you. I know that, right? So for instance, example, when you say f of x equal to 6x to the 5th minus 3x to the 4th plus 10x squared, 10x cubed minus x plus 5. This is an example of polynomial, right? We agree with that? What makes it a polynomial? What makes it a polynomial is about the exponent. All the exponents I see here, all of them are positive integers, right? All of them are integers that are non-negative. You see, in a polynomial, I cannot have a negative exponent. I cannot have a decimal exponent. I cannot have like a rational exponent. In a polynomial, all the exponents are positive integers, all of them. Okay, so this is an example of polynomial, right? Now we're going to write general form. I just gave you an example just to get the idea. So How we call, do you recall how we call the highest exponent, how we call it? How we call this? The highest exponent
The
is
leading degree?
just the degree, thank you. The degree of the polynomial of f is 5. Is the highest exponent. Okay? And every polynomial has terms. This one right here, 6x to the 5th, is called the leading term. Okay? So, and the numbers in front of the variables are called coefficients of the polynomial. The numbers 6, -3, 10, -1, 5 are called the coefficients of the polynomial. Okay, and 6 is the leading coefficient right here. Okay, so this is for some vocabulary. All right, so right here now, this is not a definition. This is an example, right? So right here, if I want to write a polynomial of degree 1, for instance, I can say f of x equal to ax plus b. Okay, that is a polynomial of degree 1. If I want to write a polynomial of degree 2, I can write f of x equal to ax squared plus bx plus c, right? Okay, so if I want to call my coefficient a, b, c, does it give me a freedom to write any polynomial? If I want to call my coefficient a, b, c, d, how many terms I can write maximum? Only
26, I think.
Only 26 terms, right? Let's say I want to write a polynomial, I want to describe a polynomial that has 100 terms. Then A, B, C, D is not enough anymore, right? That is why we prefer to write them this way, for instance. We say, instead of writing ax squared plus bx plus c, how about we write a2 x2 plus a1 x1 plus a0, you see? How about I make the exponent and the index of the number of the coefficient match? If I do that, I will be free to write any polynomial I want, right? Any. So if I want to write a polynomial of degree 4, I write f of x equal to a number 4, x to the 4th power, plus a number 3, x to the 3rd power, plus a number 2, coefficient number 2, x to the 2nd power, plus coefficient number 1, x to the 1 power, plus the last one, you see? Now I'm not bounded by any constraint. I can write any polynomial I want. I can write 1,000 of them, right? This will bring us to the general form. What is the general form of a polynomial? Is f of x is equal to an xn, you see? I make them match. If the n is degree, if n is a degree, so the first term, the leader will be an xn. What's going to be the next one? What's going to be the index and the exponent? A what? Can somebody tell me?
N minus 1.
N minus 1, which is a number next to n, going to the bottom, right? N minus 1. What's going to be the next one? N minus 2,
Yeah.
xn minus 2, etc., etc. We keep going. We cannot write all of them until the last ones, which is a2x2 plus a1x plus a0, right? This is a general form of a polynomial. So degree of f is equal to n. Of course, for the degree of f to be n, the leading coefficient cannot be 0, right? This is a general form of a polynomial of degree n. Okay. So what you're going to try to do in this section is, now that we have now that we define what is a polynomial, we're going to try to see what can we do to graph some polynomials. Not all of them, but what can we do to graph some of them, okay? So we know how to graph a polynomial of degree 1. How else, what other name we call it a polynomial of degree 1? What name we can give it? How can we call it? What function? A polynomial of degree 1.
Linear?
Linear, thank you very much. You see, like this one, f of x equal ax plus b. A polynomial of degree 2, what other name we can give it? What function is it? When the degree is 2?
Quadratic.
Quadratic, thank you. Degree 1, we know how to deal with it. Degree 2, we know how to deal with it. But degree 2 and above, you know, it's harder, right? It's harder, degree 3 and above, okay? So we're gonna see if the polynomial is nice enough, what can we do to graph it, okay? For that, we're gonna introduce a concept, a new concept, which is a zero of a polynomial. Let's do an example right here. Example. F of x equal to x squared, you know, minus 5x plus 4. Everybody, how much is f of 1? Go ahead. How much is f of 1?
Zero.
That's 0, right? F of 1 is 1 squared minus 5 times 1 plus 4, that is a 0. Because of that, because f of 1 is 0, we say that 1 is a 0 of f. You see how the name is very well chosen? Because of that, we say 1 is a 0 of f. Okay? Simple as that. 1 is a 0 of f. So, but how much is f of 2, for instance? F of 2 is 2 squared minus 5 times 2 plus 4, which is 4 minus 10, which is negative 6 plus 4 is negative 2. Because of that, what we say? What we say? What's the conclusion here? What we say? We say that 2 is not a 0 of f. So what is a 0? What are the zeros of a polynomial? What are the zeros of the polynomial? What's the definition then?
It's numbers which f of them is equal to 0.
Exactly. The zeros of a polynomial are the numbers, when you plug in them, you get 0. Okay? The zero of polynomials are the solutions to the equation f of x equals 0. When you set f of x equals 0, those solutions are the zeros of the polynomial, right? Okay? The zeros of polynomial are the solutions. We say C is a 0 of f, if f of C equals 0. That's it. Or C is a solution of the equation f of x equals 0. Right? Any number that you plug in and you get 0, any number that you plug in and you get 0, it is called a 0 of that polynomial. Okay? So now, look right here. F of x equal to x squared minus 5x plus 4, right? f of x equal to x squared minus 5x plus 4. Can you factor this? Just by chance, can you factor this?
Yes.
Is a what?
Mm-hmm.
X what?
Minus
What are the two
4
factors?
minus 1.
X minus 1 and x minus 4, right? Or minus 4 minus 1.
Mm-hmm.
So do you recognize here the one here? That was a 0. You see? Every time a number is a 0, then x minus that number, it will be a factor. You see? 1 is a 0, x minus 1 is a factor. What's going to be the other 0 then? What number is going to be the other 0?
4.
4, right? The zeros of this polynomial are what? When you set this equals 0, what are the two solutions? X equal 1 and x equal 4. The zeros are 1 and 4. So this brings us to the second definition of a 0. If C is a 0 of f, then x minus C is a factor. Okay, so there is a very tight correlation between zeros and factors. Every time we have a 0, it's like we have a factor for the function. Every time we have a factor, it's like we have a 0 for the function. Everybody see that? That is the second definition. What is the third definition? Let's say I want to graph my parabola right here. This parabola, x squared minus 5x minus 4. If I want to graph it, you say f of 1 is 0. F of 4 is 0. My parabola will look like this. These two zeros for the graph, they are what for the graph? How we call them for the graph? They are
X-intercept.
x-intercept. So this is a third definition. If C is a 0, then x equals C is an x-intercept. Okay, so the zeros are also x-intercept. Okay, the zeros are in the factoring. So all of this is exactly the same. So now let's try to learn what are the zeros. Find the zeros. Find zeros, right? F of x equals x plus 3 times x minus 5 times x plus 7 times x minus 6 squared. What are the zeros for this one?
Negative 3.
5. What
5.
next?
5.
5.
Negative 7. And 6.
Everybody sees what exactly Sharif said from what? You see, everybody see how we get those numbers that just Sharif said. We set it to 0 right here. Okay? You see, I have a complete factorization. I have the complete factorization of my polynomial. I have just set each one of them equal to 0. So x plus 3 equals 0. X, how much is x? Negative 3, right? But since this is so simple, we can do it mentally. We don't have to set up, actually. X minus 5 equals 0. How much is for x? 5. X plus 7 equals 0. How much is x? Negative 7. X minus 6 squared equals 0. The square, does it change anything? It is outside, so it doesn't change anything. So x equals 6. So what are my zeros? The zeros are negative 3, 5, negative 7, and 6. Everybody see that? Okay, let me give you another one now. F of x equal 8x times 3x plus 1 times x squared minus 9. What are the zeros now?
Zero.
0, yeah.
Negative -1/3 and 3.
And 3, right? So almost right? Almost. You just forgot 1, 0. But here, my point of giving you this one here is do not rush. Don't rush, take your time, set each one to 0, right? Each factor set it to 0. You see here, the fact we get 8x here. When you set 8x equals 0, x will be what? X will be 0, right? The 8 will not matter at all. So for this one here, for this one, the 0 is 0. Everybody understand that? Don't say 8. 8 is not a 0, everybody. Please don't say 8. Some students say 8. 8 is not a 0 here. When you set 8x equals 0, how to get x by itself? What you do? Divide by 8, right? It's going to give you x equals 0. For this one right here, what is a 0? Sheriff said it is negative 1/3, right? And how we get negative 1/3? What we did actually, we set up 3x plus 1 equals 0, and we move the one we divide by 3, right? Okay, now here, x squared minus 9 equals 0. X squared equals 9. X equals how much?
3.
Only 3?
No, plus or minus 3.
Plus or minus 3. So we have 2 zeros here, is negative 3 and positive 3. Okay? So we have 3, for this one we have 4 zeros. All right? You see, so if my polynomial is given in this form, finding the zeros is very easy. What is not easy is when my polynomial is given in another form, okay? So now, when you have this, when you have f of x equal to x cubed times x minus 6 squared times x plus 3 or x plus 2. What are the zeros? For the first factor x cubed, what is the zero that corresponds to x cubed?
0.
0, right? But look, we have an exponent, right? If you write this explicitly, it's like how many zeros you have for x cubed. If you go ahead and actually expand the x cubed, you write x times x times x, right?
Yeah, so that's 3.
And each factor has a 0 which is 0. Because of that, we say 0 is a 0 of multiplicity of, and keep this word right here. This word is very important, of multiplicity three. And the 3 is the exponent right here. You see, that is how many times a 0 is a 0. Okay, so how many times 6 is a 0?
Twice.
Twice. So we say 6 is a 0 of multiplicity of multiplicity 2. All right. And how many times negative 2 is a 0?
Just once.
Of multiplicity 1, right? Which is 1 here.
Sir,
Yes.
Oh, if the first one, 0 is okay, 0 is a 0 of multiplicity 3.
Yes.
Do you mean we can have x squared times x?
Yeah, x cubed is x squared times x, right? But if you count the factor x, the multiplicity is how many times the factor occurs. The factor x here occurs 3 times. X times x times x. If you break it down as x squared times x, it's still you still have 3 x factors. And each factor corresponds to one multiplicity. So if you add them up, you get multiplicity 3, right?
Okay. Good.
Yeah.
Thank you.
So that is the that is the definition of multiplicity. It's going to play a big role in the next, right? The multiplicity, especially in the graph, etc. So and then just before we close up this right here, I just tell you, if A and B are 2 consecutive zeros, and we know what consecutive means, right? When you say 2 consecutive zeros, what that means? It means we don't have another 0 between them, right? You see? So for instance, we say 5 and 6 are 2 consecutive integers, right? Because there is no number, there is no integer between them. There is no integer between them. When we say 5 and 8, 5 and 7, are they consecutive integers? 5 and 7 are not consecutive integers because we have another integer between them, right? If A and B are 2 consecutive integers, can we have this? Can we have this, for instance? Can we have this?
No.
You could.
It's good. Okay, let's say this happening. Let's say this is happening now. How many zeros do you see on this graph?
3.
Remember, the zeros are synonymous of the x-intercept, right? I see 3 zeros here.
3.
But this contradicts what? It contradicts what from?
They are not consecutive, right?
Exactly. It contradicts the fact they are consecutive. The fact they are consecutive means there is no 0 between them, right? Okay? There is no 0 between them. And we're going to close by that fact. If 2 zeros are consecutive, the graph between them is either all above the x-axis or either all under the x-axis. It cannot go one way above, one time above, one time under. Does it make sense? Because if it does that, if it does go one time above or one time under, then it's going to introduce another 0, okay? It's going to introduce another 0, which is going to contradict the fact they are consecutive. So if they are consecutive zeros, it's going to be either between 2 consecutive zeros here, A and B, the graph will be either all above or the graph will be either all under, right? It cannot be above one time and under one time. Does it make sense? And we're going to keep that in mind. When we come next week, we're going to use this fact right here, this simple fact. Between 2 consecutive zeros, the graph is either above or under. We're going to use that and try to graph some polynomials using the zeros, okay? All right, so we're going to stop here today. So for teams, we don't need you don't need to write your name because I can download the attendance list. I hope everybody did do the quiz on time. So and then keep in mind, you know, when you do the quiz, when you open the quiz, when I go to Brightspace, I can see when everybody opens the quiz. I can see that Brightspace tells me student X has opened the quiz at October the 19th at 3 o'clock. So when you open the quiz at 3 o'clock yesterday, and then you submit the quiz even one hour later, so you were out of time, let alone if you submit the quiz the next day, you see. I tell you that because I just had a student, you know, who sent me the quiz, you know, and then when I checked, you know, she accessed the quiz the 19th, you see, 2 days later. I mean, 2 days before today. And she just sent me the quiz right now. That is not serious, okay? So you have to take this stuff seriously, because I go to Brightspace, I see when you have access to quiz. I see when you submit the quiz. You know, it's very easy to do the math. If you exceed the time, you know, if you exceed the time with no reason, you know, like, you know, exceeding the time, you know, okay, instead of like 10 minutes, we can understand that because of the difficulties. But some excess, you know, I just cannot accept that. Okay.
Professor, I tried to
Yes.
email you about that because I was having connection issues all day.
Yeah, I got your email. I think I did answer to you. Yeah.
Okay.
Yeah, I got your email. You know, we run into problems. We understand that. But we cannot run into problems for the whole day, for instance, or for 2 hours. Or if that is the case, you email the teacher and tell them on real time. Real time, I'm doing my quiz. This happened real time, right? But if you wait after, because the quizzes, everything that comes to grade is not a joke. You see, we try to make it as, you know, as normal as possible.
I tried,
right.
my screen froze, so I wasn't able to like do anything at all.
Yeah, I know. This happened, and then I got your email and I did answer to you. Sorry about all the difficulties.
Yeah.
All right, everybody.
Like shut out of class yesterday too, so.
Yeah, I see. So do you have any questions? I will grade your quiz in the next couple of days, and then put the answers, I mean the copies, the grades on Brightspace. All right, and then you have to gear up. You have to gear up for the next test. See, the quiz is cool, you know, all that, but the test is really 15%. Okay. All right.
Are we
Thank you.
Are we going to be
Yes.
allowed to go back and you redo some Alex if we didn't complete the whole session?
So Alex here, this is like his objective wise. The objective setting is done in a way when you disturb the settings, you have to redo the whole calendar. It's not like each objective is linked to the other one, to the next one. So this is not like some free set. If it was free sets, we would do that like very easily, you know. But if somebody is doing the Alex as they should, as they are doing it, if you miss like a couple of objectives, it will not have almost no impact on your grade, almost none. The thing is now, if I was not doing Alex at all, okay, now this one will have an impact. You see, if I go ahead at the end of the semester, if I try to go ahead and reopen all of them, it will not, the setting does not work that way. Because objective, you access one objective after you complete the other one. You see, it doesn't work that way. So if you miss few of them, my advice would be try to not to miss the next ones. If you just miss like few of them, this will have almost no impact. If you just somebody missed like a couple of them and stuff like that, it will have almost no impact of the grade. Okay. If you look at the grade as a whole. All right. All right. Thank you, everybody.
Have a great week.
Thank you.
Thank you.
Thank you.